Hello everyone, my name is Mark Baines with Training Made Fun, and this will be the final segment, part 4 of Biomechanics for the Biomechanics lecture that goes along with the Training Made Fun workshop in regard to application of exercise biomechanically for most efficient, safe, and effective exercise. And now we're looking at some animations to get a better idea of what we're talking about. We're referring to torque at a given joint, where we're talking about the moment arm, the line of force, referring to making an exercise more efficient, more effective, or safe. Looking at animation here with someone doing a bent over dumbbell row, assuming the person could even bend their hip well enough to get their spine parallel to the ground. We want to make sure that shoulder stays fairly much in the same place without much movement other than basic rotation. In this animation, actually, the shoulder is actually going to protract right here, and the spine's going to rotate, which honestly is not something that's probably really desirable for a typical dumbbell row. It's not that the motion itself is poor, because generally speaking, as we have mentioned before, there's no such thing as a bad motion. However, when you add load, when you add intensity, when you add speed, when you add repetition, it changes the stress on the joint. It changes the impact that it may have, either positively or negatively, risk versus benefit. In this case, it would be much preferred if this person from this dumbbell row kept their shoulder about as close as it could be to the same spot in space, other than the obvious that it needs to be able to move into extension and some retraction a little bit as it goes backward and pulls that dumbbell upward, with gravity resisting gravity, trying to pull the shoulder into flexion as he's trying to pull that shoulder with that dumbbell up into extension. The elbow bends naturally as a process of the movement upward. It does not mean the biceps are active. In fact, technically, if he's going to properly extend his shoulder here, get the maximization of the work on the triceps, the latissimus dorsi, and the posterior deltoid, he actually should not have any biceps activation. If he does, then he's actually doing it improperly. So making it more of a bicep exercise, he'll lose a lot of the lat activation, the posterior deltoid, and some of the tricep, because the dumbbell will be pulling toward the shoulder rather than the dumbbell going back in space due to the shoulder extension. It's very important to make that designation to understand that. It's very commonplace for a lot of people to feel their biceps in pulling exercises like rows and pull downs, when in fact the bicep should not be felt at all if the movement is going to be properly performed in terms of, in the case of a pull down, shoulder adduction, in this case of this dumbbell bent over row, shoulder extension, or in the case of someone performing a high row, which is more of a horizontal abduction type motion, or reverse fly, as some people might call it. But this time, in that case, you'd be actually bending your elbow naturally, more of a row, as it is in this case. Now, dumbbell, once it's actually gone to the full extension you can with that shoulder, you'll see that that blue line is at its longest, meaning that moment arm is at its longest, and there's the highest amount of stress at that moment in the exercise on the shoulder, thereby meaning the exercise at its most difficult. That being said, because technically we could be extending our shoulder from straight over our head and coming all the way through and around, he's only actually working the second half of the motion. Not the most effective way of actually activating your lats. Not wrong, not poor, not the most effective, not the most efficient. Safe, well, as long as he doesn't get too much extraneous motion, preferably not what we're seeing in the animation. We like to use this as an example, that because it's actually what a lot of people do, and that's why the animator made it this way. We didn't necessarily want to say that's what people should do. It's what people tend to do. That said, the least amount of stress we can get with the most positive benefit will be to keep that shoulder stable, or rotating, of course, into extension and coming back toward flexion as it comes down. A little bit of retraction on the way back, but very minimal if you have any protraction on the way downward here, and definitely not getting any sort of significant noticeable spinal rotation. And of course, that dumbbell path is generally pretty good, coming backward here where it gets about a 90-degree angle with the upper to the lower arm at the top of the motion right here. That red line is more of a continuation of the line of force. If you remember from our discussion talking about the line of force, it's always consistent with the direction of where the load is, in direction toward where the resistance is. In this case, it's gravity, so it's straight down. It's always straight down, okay? And that joint is pretty much the same place, and so the moment arm is always the distance between, perpendicularly, the perpendicular distance between the shoulder, in this case, the axis of the joint, and the invisible line of force, okay? The more torque there is, the more difficult the exercise is. In this case, the exercise that is most difficult when he's actually at full shortening of the muscle, when the muscle is fairly insufficiently capable of producing force. Not the most ideal. Commonly done this way. Not the most ideal. Not wrong, but there's better ways we can be doing this. There's things we need to be exploring. We talk about it in the workshop, and in future applications and other videos we refer to other ways that might be more efficient, such as a kneeling, why kneeling? You'll have to watch that video. A kneeling, single arm, unilateral, shoulder extension type motion to activate more of the lat by actually getting more involvement from a total range of motion of the shoulder, and actually not having the exercise be difficult. It's most difficult when you're at your most weak, In fact, trying to make it more difficult when you're at your strongest, matching up that strength profile and that resistance curve, or the resistance profile and that strength curve, okay? In this case, his strength curve, he's at his strongest when the arm is straight. The resistance profile is set up such that the exercise is at its most difficult when he's at the end. It does not match up. The goal is to match up the resistance profile and the strength curve, to make it tough when you're strong, to make it easy when you're weak, not to do the opposite. There's a tendency for people to think that somehow because the person's weak, we should be challenging it when you're weak and make it easier when you're strong because you're already strong there. And that's trying to outthink anatomy. That's not the way the body works. That's trying to outthink physics. That is not the way the body works when it comes to exercise, when it comes to resistance, when it comes to activation of a muscle involved in a typical joint action. We want to maximize the benefit, minimize the risk, and the risk is actually higher when there's more stress at places where we're not as capable. So that's not necessarily the ideal thing. Like all things, this is not wrong, it's not improper to do it this way, but there are oftentimes better ways, and there are better ways of doing it. We want to take a look at those things and then get a better idea of how to better apply exercise to the betterment of the people we're trying to train. That said, we'll take a look at a typical exercise that we've all seen before, the basic squat. In this case, we have over here, first of all, very long torso and short legs. This guy is a typical person with a little bit longer legs than torso. And over here we have Mr. Legs here. We have really long legs with very short torso. And in this case, the guy over here with the long torso and short legs, not typical of most people, but some people are like this, whereby he's going to have less of a moment arm on his hip, getting very little glute involvement, maybe a little bit, pretty much no hamstring for the most part that he's going to feel or really be noticeable anyway. And then the quad, because of the significant moment arm here at the knee, and by the way, yes, his knee is over his toe, and that's okay. That's the way he's built. That's structural. To say the knee should never go over the toe is just not true. It depends very much upon the person, depending upon their length of limb and the way they move. Okay. That said, in this case, this guy's got a lot of quadricep involvement, a lot less hip. This guy has got a little more hip involvement, getting some hamstring and some glute both. Not as much quadricep involvement in this motion, even though it's technically the same concept of hip extension, concentrically upward, knee extension, concentrically upward, as well as ankle plantar flexion. They're all resisting hip flexion, knee flexion, and ankle dorsiflexion. Okay. In this case here, tall person, a person with really long legs versus short torso, regardless of what their height is, if they have a short torso and long legs, this is kind of what we're going to see. Very long moment arm, a very significant moment arm at the bottom of the motion on the hip. So there's actually significant stress actually on the hamstrings. Glutes become fairly incapable of producing force at that significant angle there of the hip and the depth of the motion there. And the knee is not getting much at all. That person might say, I don't feel much in the quads at all when we do a squat. Actually, I think squats are for your hamstrings. This guy might say, I feel squats are a little more for your glutes than your hamstrings. And this guy might say, actually, squats are more for your quads. Just because of the way they're built. They're all technically correct because of the way that they are built. But what we want to make sure happens is that line of force is consistent with direct downward line from the shoulder to the middle of the shoe. And we want to make sure that that shoulder stays directly over the middle of the shoe the entire point of the motion, entire distance of the motion. So that in this case, all three of these guys are where they approximately should be. Even though this guy might look like he's actually leaning forward too much, he's not. His shoulder's lined up from the middle of his shoe. This guy looks good, shoulder middle of shoe, and so does this guy look good. Shoulder over middle of shoe, okay? And that being said, trying to tie it all together, we have to make sure you understand what's the goal, then determine the best exercise. Don't try to figure out a way to fit a push-up into your exercise program. How should I figure out a way to get some good lunges into my program? Or let's do a good dumbbell bent over row. Nothing wrong with any of those exercises, but what's the goal? What's the best exercise? What's the most efficient, most effective, safe way of doing it? That must always be the general evaluation we use for any exercise, not just doing things because we feel it a certain way or someone told us to do it that way in the past. We have to do a better job of analyzing exercise, its benefits, and its risks. And determine individual AROM, which is essentially active range of motion. What we're really talking about is understanding specifically how far someone can move. And the extent of someone doing a row, well, technically you can have your arm all the way above your head, essentially kind of fully flexed and come all the way through down into extension, getting roughly 180 degrees or even more than 180 degrees. Whereas a typical dumbbell row is lucky to get 90 to 100 degrees of motion, barely half the total range capability of latissimus dorsi involvement, particularly. And of course, not going to get probably as much into the posterior deltoid or the in that motion either if not getting full range, let alone triceps. That said, I'm going to make sure whatever we do, that our movement when we're loaded or we're doing it fast or repetitiously that we do not exceed our ability to move. If we have too heavy of a weight or move too fast, you will actually exceed your normal range of motion and actually involve other joints in the action itself, and that should not happen for the safety of the person we're training and for the benefit of the exercise. Training VAK, make sure they were always visual. We make sure not only they can see us do the exercise at the very beginning, but during the exercise itself, mimic the motion. As they're standing there doing a dumbbell overhead press, don't be just standing there watching them do an overhead press. Mimic the press. While they're looking in the mirror, stand next to them, not in their line of sight. Don't disrupt their vision and don't disrupt their focus. So you can actually, they can see you both in terms of tempo and how you're moving, the range of motion in which you're moving, the path of motion in which you're moving, and of course they can see the general concept of technique and form that they should be engaging while they're moving. So they can see you do it at the same time, which helps tremendously when someone's trying to perform an exercise. You don't have to have any load in your hands, just do the motion. Auditorily, of course, giving form and technique advice. Be careful if you say things too often. There's a good chance the person is either lifting too heavy of a weight or the exercise itself is far too complex for the person, requiring too much coordination. If you have to keep repeating yourself with the same cues for an exercise, it's because the exercise is too much at this moment in time. For whatever reason, we've got to figure that out. But simplify the exercise. And of course, kinesthetic is feel. Putting your hands on the person, make sure they understand it's supposed to be their shoulders retracting, shoulder blades, supposed to be feeling it between here, right between your shoulder blades, supposed to be feeling it right over here in your lats, putting your fingers right there, open palm, fist, or fingers, very, very briefly to make sure they feel it. Make sure that you're comfortable with that, let alone they are comfortable with that, but highly valuable. Being active during your set, don't get caught standing still. There's no reason to be standing still. Exercises typically last anywhere from a few seconds to about a minute to 2 minutes in typical exercise, right? Barring something that's really endurance oriented. That being said, there's no reason to get caught standing still. You're mimicking an exercise, you're observing from different angles, you're discussing what's going on in form and technique, and of course giving motivational advice throughout. If you're silent and not moving, it's either because you're not paying attention or you're not really clear about what the goals are for this exercise. Monitor the path and the range of motion. It's very clear that you understand to maximize an exercise, particularly when you're loaded, particularly when you're extremely fast, or as we said, being very repetitive with an exercise. You must be clear about the path of motion, exactly what direction we're supposed to be moving, directly opposing the resistance to get the benefit of an exercise, and knowing what the range of motion should be relative to what we know about anatomy in general and the specific capabilities of the client you're training. Spine's number one. As far as we're concerned, everything you do, spine's the most important thing to be looking at to give an exercise. If your spine goes out of alignment and you try to move your arm, you'll notice if you actually round your back completely, try to raise your arm into flexion, it's not going to move very well. Likewise, if you fully flex your spine and get a posterior pelvic tilt, try to move your legs, you're not going to get much motion. Do the opposite as well, laterally flex or rotate it, however you want. You'll notice how dramatically it affects your limbs. Spine's the most important thing as far as we're concerned for making sure that's in its proper alignment. In most cases, that's neutral. Okay, it's neutral, so you got to know what neutral is for each person when it comes to cervical, thoracic, and lumbar spine. And that being said, there are some motions where they'll be moving their spine, but not while they're doing overhead press or while they're doing a squat. Maybe they're doing a rotation with a cable. Okay, there you go. Otherwise, the spine's probably going to be neutral almost the entire time, or as close to as possible. Joints moving are second. So if we're doing an overhead press, then you're looking at the hands gripping the dumbbell, the elbow, the shoulder, okay, after looking at the spine. Spine being cervical, thoracic, and lumbar spine. Everything else matters though too. Foot position, hip position, how's the knee in relationship to the hip? Are they getting extraneous motion going into hip flexion, hip extension? Are they staying still? All those things matter. It's a lot to look at. You should run out of time to look at things because the time of the set's already over. There should be no boredom or no, I'm not sure what to look at right now. There's plenty to look at. Not enough time to do it. Time the set and remind the client of tempo. No more counting reps if we have our way here. We don't want you to count reps. We want you to go for time. The number of reps is based on time in the first place. The reason why maximal strength or power is only a few reps, why hypertrophy is anywhere from a few reps to a little over 10 reps, typically speaking, or why endurance type work or functional or movement skill type work tends to be 15, 20 plus reps and above, is based upon the duration of time of a set, based on that and the tempo or the speed in which you move. Your job is to understand what the speed should be, which 99% of the time in the weight room area with external load is slow, unless you're doing Olympic lifting or someone is doing speed work, which means not loaded. Otherwise, we're talking about someone moving pretty slow, or fairly slow at least, under control always, and making sure that you're clear about what the time should be. That's program design, but you have to know that by understanding energy systems, muscle fiber types, and the goal of the exercise. And of course, make sure you're consistent with those work and rest periods. Knowing how much ATP is required to be replenished for a given rest period, it's not based upon what we read in a book somewhere, it's based upon physiology. The things we talk about in exercise are based on kinesiology as a whole, which includes physiology, understanding the body, how the body undergoes stress and how that stress can improve or can actually cause risk to an individual. Biomechanics, applying physics to the body, understanding how more specifically exercise can affect the body negative or positively, right? And it goes much broader than that in terms of the applications in much greater depth. We're barely touching upon it here. We have a much greater responsibility than a lot of us take seriously enough. Please make sure you take the time to understand these steps, continually go over and over and over them to understand the concepts of biomechanics, how to best apply exercise to make the most beneficial exercise application for everyone that we train.